Hi, a couple of people in the previous repair video of the Keithley 2302 with the failed vacuum fluorescent display here, they pointed out that it may actually not be the vacuum fluorescent display because there's no indicator of potentially losing its vacuum. For example, the getter down here has not turned to a different color like white. So there may not be an actual failure in the vacuum fluorescent display itself, the VFD display. It may still contain its vacuum and it might still work, and that is certainly possible. Now, the getter down here, this is basically a seal where they seal it up, and it uses barium usually, I think, in there, and it basically stops any other potential. It doesn't stop the vacuum getting out, it stops other gases getting in there and actually contaminating in the vacuum fluorescent display, where you can, typical failure mode might be dark spots or something like that. I thought we'd take a look at, did anything else actually fail on this board? Because obviously the vacuum fluorescent display needs a higher voltage. It doesn't just run off, a 5 volt TTL type stuff. That's what this boost converter here is for. So but basically you feed 5 volts in here and all the logic and everything else is running off 5 volts, but you need to generate a higher voltage for the vacuum fluorescent display. And that's what this little boost converter here is actually doing. That's why they got a 50 volt cap over on this side here. They've only got like a 10 volt cap because this is obviously on the input, and I'm sure if you follow the money, I'd be willing to bet that would go over to the positive input here, which I've soldered some headers on. Yeah, there it is. It goes over to the 5 volt input there. So we've got a 5 volt, so we've got a 100 mic input cap there, and we've got a 10 mic output cap on the boost converter here. And if the magic smoke escapes, the magic electrolyte inside there escapes, the ESR goes through the roof, the equivalent series resistance, and your DC to DC converter doesn't work too well anymore. So now you'll notice that there are no splits in the top of this. There's no vent in the top of this. Okay, so that indicates that this is not a wet electrolyte aluminium capacitor here. It indicates that it's probably a solid polymer capacitor. So less likelihood that it'd fail, but certainly possible. So I thought I'd just power this thing up and actually measure the output voltage, which should be across this cap here. And also, somebody mentioned that this sticker here, the glue on the bottom of that, well, it contains adhesive, obviously, that's why it sticks, but that could become potentially conductive. That's no good, is it? Actually, I probably shouldn't take that off. I should power it up first. But yeah, if the glues become conductive, for example, oh no, that's just flapping around. That was flapping around in the breeze on its own, was it? Yeah, I don't think that's an issue. But technically, if and it's only over the solder mask, but it is over a couple of pins there. But technically, if the glue under there, absorbs some, or the paper absorbs some, paper sticker absorbs some moisture or something like that, you can get a lower impedance path, and that might upset the apple cart and the wheels might fall off your billy cart. So let's power this thing up here. Pin 1 is negative. I've got the power supply up there, the positive 25 one. I've set it to 5 volts at 0.4 amps. It was already set to that. That seems good enough for Australia. Now, we won't see anything on display because it's not driving anything. Often with these displays, there can be like a test mode as well. In fact, I've done that on I'll link in a previous vacuum fluorescent display video, and I've got like how it works and things, I think, on vacuum fluorescent displays and stuff like that. So I'll link that one in if you haven't seen it. It's really interesting. And I actually reverse engineer just a junk bin vacuum fluorescent display and actually drive it. And they can have test modes, and I got lucky with that one. It had a test mode where it actually put all the letters of the alphabet up on the vacuum fluorescent display. So there could be something like this here, but you'd have to read the data sheet. Oh, and by the way, I totally missed this. With my aging Mark 1 eyeball, I totally missed that the actual part number is actually on a sticker here. Here it is. So that's the modern part number, M0216SD, blah, 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 blah. That's the one that we actually found on the Newhaven display. So this one up here, this VFM, was a furphy. So I was searching for this, part number because there it is, trap for young players, right? I'm still young, thank you very much. And I didn't see that. So let's actually peel this sticker off and see what part we've actually got under here, shall we? Oh, that's just come a gutser. Look at that. That just floated right off. Put a bit of spit on that. There you go. It's an RT63140-001 jobby. So there you go. All right, so let's switch this supply on here, and I've got it the right way around. Yeah, that helps. Yep. So, well, constant current there initially for a few seconds, but there you go. It's drawing 150 milliamps. That sounds good enough. So let's actually measure this. Now, we could have gone in there and just measured in circuit first, these caps, and I'll do that later. Let's see here. What voltage do we get? 36 volts. All right. So 36 volts sounds okay. I don't know what the voltage is supposed to be, but 36 on a 50 volt cap sounds quite reasonable. So it ain't that. Yeah, so without actually having a schematic, it's harder to do this, but we'll just probe around. Well, hello? There's nothing on that. There's no voltage on that. Why is there nothing on that cap whatsoever? And by the way, tantalums are marked differently. Tantalum with the black stripe on there, that's actually the positive terminal. Go figure. Whereas on an electrolytic cap like this, the negative up there indicates the negative. So yeah, trap for young players, that one. Just be aware of it. Aha, that's why. It's a negative supply. There you go. Minus 5 volts there, minus 5.5 volts. So, yeah, so out of that converter, they're getting 36 positive, 36 volts and minus 5.5 volts. And what voltage is that cap? 106, no, there's nothing there. Might be 5.3, but I don't think that's it. No, anyway. Negative, so we're at least getting a negative. If I was getting 0 volts on that cap, then I'd be going, well, what's the purpose of that cap? Something's wrong. And you'd chase that one down the rabbit hole. But obviously, we're getting our negative voltage on there. So that converter seems to be doing its basic job anyway. I mean, you know, there could be something more subtle in there, like, you know, the ESR in this cap is gone cactus or whatever, and it doesn't like it anymore, and there's excess ripple. I guess we could look at the ripple. Okay, sorry, I can't show you full the board at the same time, or I can, but I don't have the ATEM switcher set up. So I'm going to probe the that 36 volt rail. There we go. So 10 volts per division, 10, 20, 30, 36. So, you know, it's got a bit of ripple on there, but it's nothing to write home about. Okay, probing the negative rail now, down to 1 volt per division. Sorry, you can't see that's under my head there. But yeah, negative 1, 2, 3, 4, 5, and that's a fair bit of ripple, isn't it? Yeah. So if we put the trigger down there, and we expand out that time base, slow updating. But yeah, that's a fair amount of ripple, isn't it? But once again, might not be anything to write home about. You know, as a first pass guess, you'd say that's not really much to worry about there. Hang on, what's going on here? I'm probing the 5 volt rail. 3, 4, 5. But it's got massive ripple on the 5 volt rail. Wow. Bueller. Does that mean that whoop, focus you bastard. That input cap is Gonski? Because if that's Gonski, right, and your switching converter is pulling big gulps of current every time you switch, and there's no local bulk decoupling here, this little piddly C2 here is not going to be enough, then it's got to come through all the inductance of all this twisted wire and right through the test leads are right back to the power supply. So that's interesting. I'm going to measure that cap. Like I said, we could have done that as a first step. I think there might be something going on there. Now, I've done a video on this, how you can usually, not always, measure caps in circuit. So let's just measure this one over here, which I think is probably good. Let's just see if we could do it here. Measure at 1 kilohertz, 9.9 microfarads, something like that. What you do, little pro tip, is you swap the polarity just to make sure there's no active junctions in there that are causing you to kamagutsa, but that is a 10 mic cap, and it's measuring pretty close to 10 mic. That's not a coincidence, is it? So, and likewise, we can measure the tantalums here. Let's measure the tantalum, a 10 mic. I think that's a 10 mic cap. Let's measure this one over here, even though this is part of the digital section. And, well, come on, 4.7 mic. Yeah, that looks different. Yeah, that looks like a 4.7 mic cap. And this baby over here, 119 nanofarads. Hello? Am I not pro? No, I wouldn't. The probes would be making contact at 119 nanofarads. It's not peak. It's not puff. It's not picker. 190 nanofarads both directions. Let's desolder one end of that cap and see. Wow, we might have found a culprit. Local decoupling. Pop him off there, shall we? There we go. Let's measure him out of circuit. 700 ohms. Yeah, that capacitor's kamagutsa will force it into capacitance mode. 2.7 microfarads. Yeah, that's really, that's terrible, Muriel. Yeah, that one's completely kamagutsa. So there you go. Is there nothing wrong with this VFD display? Can I get it back into action by putting some local decoupling back in here? Wow, like I would have expected, like if any cap was going to fail in here, it'd be the output cap, because the output cap generally has greater stress on it. By stress, I mean, you know, pulsing current on it. But if you don't have a low enough equivalent series resistance here, then you get a big amount of ripple there, and that can cause a problem elsewhere, even though we were still getting our 38.6 volts or whatever there, even though we don't know what the voltage is exactly supposed to be. But, you know, looks like it's in the ballpark, but if it's got too much ripple, then... But you don't know what oddball problem, you know, that's, you know, something could be on the margin somewhere or something, who knows. But I'm going to replace that, so I need 100 mic, 10 volt. Do I have 100 mic, 10 volts? I do. Look at that, 20 of them. These capacitor kits are very handy, by the way. You can get them cheap on AliExpress, no problems, or eBay or whatever. There you go. It's significantly smaller there than the old one, but, you know, that's good enough. Now, of course, if I didn't get lucky in my previous video and happen to have those that LCD replacement available in my junk bin, then I might have actually had a go at this board and had a squiz on it, potentially, just for funsies. Maybe I would have discovered this, but it doesn't mean this is going to fix it. But anyway, let's try that again. Okay, let's switch back, and I will probe. Okay, there's our 36 volts at 10 volts per division. That looks better. The ripple on that looks better, doesn't it? So I can take that down, and I can go to 5 volts per division. Yeah, it certainly looks better than before, although I didn't actually AC couple that and have a squiz, but from memory, I think it was thicker than that. Yeah, so that is very nice. And the minus 5 volt rail, there you go. It's the minus 5 volt rail, and that's better. Oh, what the hell's going on? Is there like a bad ground connection here or something? Once again, I'm on the 5 volt input. What's going on with this scope? I swear I'm in DC mode, DC coupling. I've measured the voltage with the voltmeter on there, and it's 5 volts. This is the input across that cap. I'm going to turn the power off and on again. What the heck is going on? 36 volts, it goes off scale. Yet 5 volts, it doesn't go off scale. All right, I probed the capacitor next to it, and I'm getting this. Okay, so once again, we've still got some ripple there, right, on the input, but so do we need a beefier cap? I think there's a PCB contact issue. Probing, no, it's the probe on the PCB. There you go. I can't remember what it was before, but was it that value before? Still seems a little bit much, but we'll take it. Actually, what I might do is I might take that back off, and I might replace that with a 470 mic jobby, because I've got a 470 mic 6.3 volts. because that one was a bit weedy. So even though the original was 100 mic, with the bulk decoupling like this, you can't go wrong putting in a higher value like that, really. I mean, so yeah, I'm gonna, or does it fit? Oh yeah, I'll make it fit. Okay, so let's plug the power back into there. Now have a nice big fat chunky 470 mic in there. There you go. That's better, isn't it? Beauty. So unfortunately, the problem now is that I can't really test this without having a test mode or something like that, which I don't think it has, without actually powering it up, putting data in there and powering it up. So I either need to take apart and desolder the original unit, or I need to have like another thing which generates some LCD signals that can drive this. Alright, I decided to desolder the other one, and I've tried it, and nope, sorry, no joy whatsoever. So although those ripple voltages looked okay, I decided, nah, I'll just go the whole hog and I'll replace all three of those caps. So that's what I've done. I've actually replaced that one up there and the tantalum jobby with an electrolytic here, because I didn't have a suitable tantalum, and I went back to the 100 mic down here. Unfortunately, the pad lifted off, so I had to just bodge that over there. So I've got just the existing caps. This one over here is nothing burger. That's just a digital thing there. So, well, no, that looks like, is that like a power on reset thing or something? Maybe. Anyway, I'll give that a whirl. So I'll measure the voltages again with all new caps. Okay, that's the 36 volt rail. Doesn't look any different, does it? And that's the negative rail. And again, that doesn't look any different, does it? So, and that's the 5 volt rail. So yeah, no difference. So we definitely fixed the 5 volt rail, but anyway, I will put that in and see if recapping that has made a difference or not. But from the waveforms, it doesn't look like it's made any difference. So anyway, I'll desolder that and whack it back in. Okay, it's last attempt, I think. And whoa, hello. Whoa! Winner, winner, extra chicken dinner. Do you believe it? Wow, those waveforms weren't any different whatsoever. Yet it is recovered. Okay, so there was absolutely nothing wrong with the VFD module itself. Subtle difference in the ESR or something, perhaps. That's quite surprising. Wow. Now, unfortunately, it's actually not very bright without the filter, and with the filter, I don't want to solder it back in yet. So we got dodgy characters. Keep pressure on that. Yeah, I think you're seeing that on camera. Yeah, it's not very bright, unfortunately. Now, in theory, it's sometimes possible to actually rejuvenate a VFD like this. You can put like a high voltage on the grid or whatever, and you know, you can like burn some stuff off and potentially do that, sort of rejuvenate the brightness a bit in that way, but you've got to be very careful doing that, and it doesn't always work, not guaranteed. But the other reason it could be dim is just phosphor degradation in there, and well, there's nothing you can do about that. So really, like, yeah, okay, winner chicken dinner, we got it working, but now I've got a choice. Do I actually put this VFD back in, or do I put the LCD back in? And, well, this is really quite dim, and it's touchy and temperamental, and it's probably just going to, the phosphor's only going to degrade over time anyway, so I'd probably have to change it in another few years' time anyway. I don't know, so it's a gamble putting this thing back in, how much life it's got left. So I think the sensible choice is to put that junk bin LCD back in. And it kind of feels nice knowing that you know, found it in the junk bin, of course. So yeah, sorry for those who want to see the VFD replaced in this thing, but I think for the long-term prospects of this and for readability, the LCD is going to be better. Now, I might actually see if I can change the lead dropper, find the lead dropper resistor there, and like halve that or something to get a brighter display on that. But of course, the LCD is going to last forever, and it's going to be brighter. And so unfortunately, I don't think there's a contest. And no, I don't, as some people mentioned, like, yeah, okay, I can go out and buy a blue OLED display or something like that. I might be able to get a compatible version with the footprint and the pinout and stuff. And well, no, I couldn't be bothered spending money on this. The whole idea is that, you know, I got the thrill out of repairing it with a junk bin item. So yeah, I think I'll do that. So R7 there is the lead dropper resistor. I measured that. It's 100 ohms. So yeah, I might just halve that, drop it down to 47, and that should give me a brighter backlight. No worries. And the voltage on that LED backlight, I measured that at 2.8 volts. So, yeah, we're talking about a 2.2 volt drop across the resistor. So with the 100 ohms on there, it's about 22 odd milliamps, standard sort of LED current. But if I halve that, I can get that up into the 40 milliamp range, and it'll still do it, considering that, like, I don't leave this thing on like 24/7 or whatever. I think we're pretty safe doubling the backlight current on that. There we go, that's brighter than last time. So yeah, we'll whack the filter on that, and Bob's your uncle. So there you go, that's normal lab light in here without the like main studio lights blaring in the face of it. Next to it, I know it looks a bit dark, but yeah, it's not. And there it is with just some extra, yeah, the overhead, you know, studio lights on when I record. So it's not too bad. I think it's brighter than it was before, and it's more readable than the vacuum fluorescence. Sorry to anyone who wanted to see me put that back in for nostalgia, but no, sorry. Confidence is not high that this thing will last like another 10 years. I greatly doubt it. It's on its way out. I think probably, you know, the phosphor's on its way out on it, and yeah, it's just, no, sorry, LCD replacement. And no, for those who want to get a blue OLED or whatever, sorry, I'm not going to spend any more money on it. I like the fact that I used my junk bin to get a matching LCD for that. So I'm pretty happy. Anyway, that turned into a very interesting part too. So thank you for spurring me on to actually take a second look at this, because I got all excited in the first video that, hey, I found the junk bin display, and yeah, fixed it, no worries. And for those playing along at home who are interested in the ESR of the caps that we took out, that's the 50 volt jobby there. There you go, 2.7 ohms at 100 kilohertz. That seems a little bit high. And this is the input cap. So this is the real horrible jobby. 530 ohms. Yeah, nah. Like a typical good value for one of these. Like this is the 470 mic, for example, that I put in, and it'll be like, you know, hundreds of milliohms, half an ohm maybe, something like that. Yeah, 0.4 ohms. There you go. And the poor little baby tantalum. Actually, that half an ohm. So that's pretty good. Actually, that's actually really interesting. So yeah, half an ohm, like that's the one that potentially gave the problem. But as it turns out, there was more to it than that, and it looks like it might have been a combination of the main input cap failing. That failed big time, and the maybe the it looks like possibly the tantalum in there as well, because I just had a look at the footage, and I noticed that the wave shape did actually change on that one too, as when I put the electrolytic in there. So the wave shape changed, and it dropped in amplitude a little bit. So yeah, just fixing the bulk decoupling, he put a massive one on there, didn't fix the overall issue. Whatever it is that was causing this thing not to display anything at all, leave it in the comments if you want to speculate on that. But yeah, so a combination of those, and I'm sure there's people in comments, oh, I should just recap the thing to begin with. Yeah, whatever. I was excited to get my LCD junk bin win. Thank you very much. Anyway, if you liked that video, please give it a big thumbs up. As always, discuss down below. Catch you next time.